All right, we are going to cover command line today's lecture, and that's how you can run command line programs from Python. So we haven't explored a ton of command line programs yet, but you should be familiar with a few. For example, grep we covered, which allows you to identify lines of a file that match a certain pattern. For example, if we wanted to find all of the parts of the world demographics file for a specific country, we can use grep to filter that. So just as a reminder, the world demographics.csv file is something that lists the age and the number of people that live in a specific country. So this first line lists the number of people in Afghanistan that are age 0. So there's 1,134,501. So if we want to filter this for a specific country, you can do that pretty easily using grep. So grep, we give it the pattern to match, in this case the name of the country, and then the file. And so it outputs all of the lines that match that. So now we have just the files, just the lines of the file that are specific to Algeria. And we could do this, for example, for any country that we're interested in. So if we wanted to look at Canada, we just have to change this into Canada. So let's say we wanted to do this now in a Python script from the Python interpreter. So we can't call grep from the Python interpreter. It doesn't know how to run that command. So if you want to run a command, what you need to use is and rely on is this subprocess module. So the subprocess module you can simply search subprocess in Python, and then you will get the manual page and the documents for how this module works. There's a large number of different functions that are within this module. There are 2 of them that we're going to cover in this lecture. The first one is called run, and then the second one is called popen. The first one is actually a function, and then the second one is actually a class to create a specific type of object. So these are 2 very useful parts of subprocess. And there are 2 distinctions that are important to keep in mind when you're using them. So run, this command is a blocking command. So what this means is that if you use this, the Python script runs this command and then waits for it to finish before moving on to the next line of your Python code. Popen is a non-blocking command. This is also sometimes called an asynchronous command. So what this means is that the Python script immediately runs the command, and then it spawns it in a completely different process, so it's able to run independently without waiting for that function to completely run before moving on. So the reason that you can do things like have Adobe Preview, something in order to look at a PDF open. You can also have Google Chrome open. You can have Terminal open. Is that each of these is run by spawned by different processes. And if you're ever interested to see like how many processes are running at a given time on your computer, you can use the top command, and then this will list all of the different processes that are running. So you can see there's a huge number of processes. So I, for example, am using Camtasia, which is how I'm recording this video. But you can see that there's a huge number of processes that are running at any given time. So these can be Python, these can be Adobe Illustrator, these can be all sorts of different things. So the other thing that popen is useful for is piping, and so we'll recover that in a little bit so you can see again how it works. But first, let's just try to figure out how to run a command within the interpreter. So you have to import this module subprocess, and now you can use this command subprocess.run. And so it's taking in a single argument here, and this argument is a list. And so this list is the name of the program and then all of the commands of the program as separate elements. So this is a list with 3 elements in it. Again, the name of the command, so this is a string that we're providing it, and then 2 other strings that list the arguments of it. So we're saying run grep, search for the string Algeria, and then use the file worlddemographics.csv. And so we can run it. And so what we see that gets printed out is all of the lines of the file that match that. So that's kind of as expected, along with this completed process string that was not part of the file. So you supply a name. Okay, so we've covered this. And so if you wanted to say capture the output of this, you can do that. So we can just call this output, let's say. And so what you'll notice though is that all of this continued to print out to the screen, with the exception of this completed process. So what we've captured is simply this completed process object that contains a couple of different things. So let's just play around with this. So for example, if you want to see the arguments of the command, you can use this args keyword, and then return code tells us if it works or not. There's also these standard out and standard error, but these are actually empty. So now let's move on to the next part. Let's say we wanted to capture the output from a command using run. So it's nice to be able to run this command, but we probably want to be able to capture and process this data. And right now we're not capturing this data. This data is simply being printed out to the screen. And so if we want to actually capture this data, we are going to modify this in a couple of different ways. So there are 3 modifications to this. So one, we specify how we want to capture this data. So we save this data to this variable called output. I'm also, in order to make it a little bit easier to parse through this, I'm also only going to read in a single line of the data. So I did this by adding this 287 comma in front of it. And so this allows me to filter to this specific line. So I'm just searching for this string so that I can return just a single line of code, because it's easier to kind of go through the next steps without having this entire set of data. And then finally, the file is the same, and then I'm adding this optional argument called capture output equals true. And so now we're able to capture the output of the program. So this grep normally prints stuff to either standard out or standard error. So if we ran this incorrectly, it would output information to standard error, and then capture output equals true tells us to take that data and store that. So now if we look at output, we notice that we still have the args. This is the command that was run. The return code, so return code equals 0 indicates that the program ran successfully. And then we see that there's something in the standard out variable as well as the standard error variable. So this is good. And to access all of this, we just use the dot operator. So if we wanted to access the standard out, we would do that. And standard error, we would do this. So hopefully you've noticed that this looks a little bit different from any object that you found before. So it kind of looks like a string, but unlike a string, it has this B in front of it. So this is not actually a string. So another thing that you have to get used to when you're using this subprocess is that the standard output standard out. This is actually a bytes object, so it's no longer a strings object. And so if you wanted to see what exactly this output is, we can actually print it. So let's do this. So let's go in here and we'll iterate through every single element of that. Let me get the syntax right. And now if we just print element. So that's interesting. Instead of printing 287 comma ALGERIA, what it's actually printing is numbers. So each one of these letters is a number that gets printed out. And so this is why it's a bytes object. And so a bytes object ranges from 0 to 256. So 0 to 255. So it's essentially a list of numbers that we have within this. And so if you've ever heard of this, might not make a lot of sense, but it actually might help you understand some things, some names, some words of things that you've probably heard before. So ASCII is an example of that. So hopefully you have heard of ASCII before. And so what ASCII is just a way to encode characters. So the way characters are encoded, so these can be letters, for examples, these can be numbers, these can be things like operators like minus sign, plus sign, star, etc. And then it can also encode things like tabs, backspaces. And so the way that this is encoded is that there is a number that ranges from 0, so ASCII is actually only 0 to 128. And then these numbers encode certain characters. So 50, for example, if we, this first element was 50, and so if we find 50 right here, we see that this is encoding a 2. And so that makes sense. The first one within here is a 2, and then the 56 equals a 8. So you can see basically how this 50, 56, 55 would be encoding this 287, Algeria. So ASCII is one possible way to encode data. The problem with it is that it's very English-centric. So all of these letters are from the English alphabet, and so this becomes problematic if you want to encode other alphabets or languages. So a more universal code that we use is called Unicode. And so this Unicode can include letters, but then it also includes other characters that are common, for example, in Greek alphabets, etc. So kind of some of the other alphabets, and it's possible to encode these different letters. So Unicode is very large. There's actually a large number of more than 256 possible characters in the entire Unicode table, but you can also specify a 8-bit encoding version of that, and that's called the Utf-8 library. So typically this Utf-8 is what we want to use in order to decode data, assuming we are using a kind of English, we're coding in the English language. So let's see now how this works. So we have our bytes object, so output.standardout. We have our bytes object, and so if we want to decode this into a string, we just need to specify what library we want to use. And so now we've got a normal string object that is returned. So we could have also done this with ASCII, and so in this case, both of those would give us the same translation. So you'll notice, for example, this new line character, this /n, that is encoded by this 10. So this is a new line feed, a new line. So ASCII also includes a way to encode, both ASCII and Unicode include ways to encode new line characters. All right, so if you want to specify the decoding when you actually run it, you can. So we have done this capture output equals true. We can also supply it with an optional keyword, and this specifies the table that we want to use to decode the bytes that are returned. And so now this standard out and standard error is not a bytes object, but it's actually already encoded as a string, and this is typically how we want it. So typically whenever I run subprocess run, I specify the encoding when I run it versus encoding the standard out and standard error in after the fact, but you can definitely do it both ways. So if we wanted to now go from just a single line, but instead capture the entire country. So now we have a bunch of different lines of this file, and they're separated by new line characters. And so we could simply do something like this. And so now we have a list where each element is a line of code, and then we can do whatever else we want in order to continue to analyze it. So if we wanted a list of the populations, we could do something like this. Whoops. Sorry, this is a string. So if we wanted to do something like we could do something like this, and use all of our string and list Python skills in order to eventually get the population as a number in a list. So I just used some of our splits and some of our list comprehensions, and I used the integer to convert it to an integer. And so now I have the population of Algeria by age as a list object. And you can do additional things, additional types of things as well. So this is kind of a straightforward way to use grep. We don't have to rewrite grep. We can take advantage of the fact that the bash shell comes with this great command, and then we can use this in order to get the data that we want with pretty minimal amount of code. So we'd need a line of code in order to run subprocess, and then we need a line of code to kind of process that data the way we want it to. So this is one of the powers of Python, is that you can really do a lot of things with very minimal amounts of code.